Okay, so this video is going to show how to do simple packet processing. So it's just a video I thought of doing just to share what what I learn once in a while. So I'll show you how to do simple packet processing in C. So basically, packets are used to store compressed data. For example, when you're working on a network and you want to share data to the network, you compress that data into a packet, then you send it. For embedded, when you want to share data to other peripherals, for example, an LTE module or a Wi-Fi module or UART, you basically compress that data into a packet, then send it to the destination. So basically, you can have different types of packets. You can design your packet to be a JSON structured type. You can have it as a string, CSV string, or you can go further and embed your code into an hexadecimal packet. And that hexadecimal packet is what we are going to decode in this, create and decode in this video. So I'll just open Paint to explain what I'm saying. So Paint is easy to use, so I'll just use it to illustrate what I mean. So basically you have size, yeah. So we have a structure here. A structure, let me draw. Let's assume this is 32 bits. Yeah, which is basically 4 bytes. 4 bytes. 4 bytes. Yeah. Now, if it's 4 bytes, 4 byte, if it's 4 bytes, means that we have 8 bits per byte. Obviously, you know that 8 bits per byte, and for those bits, we are going to store different length of messages inside those bits. So I'll divide this structure into a simple packet. So let's say this is 1 bit, or no, let's say this is 2 bits. Let's say this is 1 bit. This can be, let's say, what, 12 bits. So that's 12 plus 3, that's 15. Let's see what else we have. Let's have something else here with 3 bits. Another one with 3 bits. 12, 15 plus 6, that's 21. We have 9, 10 more bits to go. So let's say this is what, 4 bits. 4 plus 3 plus 3, that's 10 plus 12 is 22 plus 3, 23. So 32, 23, that's 9, 0. So we have 9 bits to go. Let's say we give this 4, then this 5 bits. So basically, let me just correct this and write here 4, and then I make this 5, and I make this 4. Okay, so these are 2, 3, plus 12, 15 plus 3, 15 plus 6 is 21 plus 4, 25 plus 5, 30. This is more than whatever I need. So this will be 2. 2. This is, yeah, this should be 2. Just to confirm again, 15, 6, 21 plus 4, 25 plus 5, 30, 32. Okay. So a packet can be simulated basically to contain different message inside it. So we can have something like the message itself. You can have the message here, also known as the payload. This is the payload. Okay, payload. So payload is 12 bits. You can have some form of like check, maybe a cyclic redundancy check like a CRC. We can have something that can be 1 bit, let's say status, or let's call it state. Okay. CRC state payload or the message. Then you can have things like other values. Let's say this is a voltage. Let's say we are measuring voltage in a system. Let's say this is current. So this is current. So you can see that there are 3 bits. So the maximum current that can go to is 8, a value of 8. Assuming this is an hypothetical scenario. 4 bits can have like, I don't know, the address. Okay, address. Let's say this is what? Let's say the, I don't know, parent. I don't know what that is, but hypothetical. Parent address, maybe. Parent address. Then this can be something to do with, let's say, read write. Read write will be 1 bit, but let's just call it read. Hypothetically. Okay. So when you have such a packet, you can embed your code, your message, your data inside here. So the packet, the packet may look something like 0x. Remember that it's an hexadecimal value, so it can be A, B, 1, 1, 2, 4. These are just random numbers. A, B, 1, 2, 4, E, C, D, for example. So it's 32-bit because this is 1 byte, 2 bytes, 3 bytes, 4 bytes, right? Okay, so let's translate this into like piece of code we can actually use. So what I'll do, I'll open an editor here and say I create a file that's got packet, let's say packet.c. Okay, so packet.c, I should be able to see it here, and I translate these values into a structure basically. So I have a CRC, which is the least significant bit. I have a state, I have payload, I have voltage, I have what else? Current, I have address, then there is the parent, address. Finally, we have the read, yeah, whatever, read. Okay, so obviously the first thing we do is create a structure for that. So first of all, we include the standard library, stdio.h, stdio.h, and then you create a structure. So we can, there's two ways of creating a structure. You can call it struct packet. Let's call it packet. Then we close that at the end. This auto completion thing is just messed up, but anyway. So we have, now this is important, we have 2 bits to store the CRC. So the closest that we can go to a data type that is 2 bits long is an 8-bit integer. So we can have an 8-bit T integer CRC. So mind you, this code is not optimized. So you realize that we are storing like only 2 bits in an 8-bit. So we are wasting around 6 bits. But I'll show you how to optimize that maybe later. Next is state. So we int ht state. The other thing is payload is 12 bits. So if it's 12 bits, we can use 16-bit integer. 16-bit integer. So this should be around 16 bits. So uint 16 t payload. Okay. Then we have voltage. So those others can go into 8-bit integers. Voltage. Then you have uint 8t current. You have uint 8t. So we have voltage, current, address. You have address. Then uint. So this parent address is 5 bits. So it should be ht parent address. Let me shorten this. Then we have unit 80 read. So this is 2 bits. This other guy is 1 bit. Payload is 12 bits. This voltage is 3 bits. Current is 3 bits also. Address 4 bits. I'll just write all of them down here quickly. Parent address 5 bits. And read this 2 bits. So this is 2, 3, 15, 18, 21, 25, 30, 32. Right. So I just paste this here. Next is create a main function. Main. Okay. Let me just turn off this auto completion thing. So general inline completion disable. Apply. Okay. So we create a struct packet, okay. And then next thing is we basically ask for the packet, or you can just have like int int 32 t packet, say p is equal to 0x, something to do with, let's say 1 2 3 4 a b c d. Okay, this is one option. The other option is to ask it for it from the user. So you can say enter 32 bit packet, right? And then now you say we scan this into the address of the packet. So packet, and then the type is it's a decimal file, it's a decimal variable, 0x percentage x, sorry. Okay. Okay. Next is, now how do we decompose this struct and 0? How do we decompose this packet? So we want to basically extract these bits, yeah, from this packet here. We want to extract these bits from this packet. So what you do, you play around with bit manipulation techniques. So we can say packet, now this packet here dot crc is equal to, now remember this crc is holding 2 bits, 2 bits. So if I open a calculator just to show you like what I'm saying, if I go to a binary view, these are the 2 bits I'm talking about here. CRC is holding 2 bits, so I need to extract this from the packet, right? So for me to extract, we use for extraction of bits we use the AND operator. So what I can do here is say packet dot crc and with whatever this is 1 1, in hexadecimal is 3, so you AND that with 0x03, you should be able to get this should be packet, you should be able to get the last two bits. Okay, if you say packet dot the next thing is state. So state is taking 1 byte, I mean one bit here. Now we want to extract 1 bit, and we have already extracted these 2 bits. So how do we get rid of these 2 bits? We right shift. Basically we dump away these last 2 bits. So what we do for us to get the state, we'll say first operation we do is say packet, we shift by 2. 2 is the length of the CRC, and then we AND with the length of state is 1. It's 1 bit. Okay. Now when you right shift by 2, it means that the state is holding the leftmost significant bit. So it's something like this. This is 0011. Let's have something that resembles that. No, 11. Yeah, something like that. So if I shift this by 2, I'll get I'll basically get rid of these last two. I'll remain with this. So I'll get 0, 0, 1, 1. So this is LSB here. So, so this operation, this is what it does. So the state is this guy, but now it's 1 bit. Okay, so we AND this with our bits of interest is only 1 bit. So this is a bit in hexadecimal is 1. So 1 is 0x1. Now, one thing I should mention is that once you finish this operation, you should convert this data type back to whatever it was. So we cast it back to uint ht, and then we do the same for this crc, which is uint 8t. Right. So that's that. So we do like this for the next. So the next one is packet dot payload is equal to. Now we have already used 2 plus. We have already used no. We have already used 1 bit plus 2 bits, so 3. So what we do, we dump them. We right shift packet by 2. Okay. So right shift by 2, not by 3, and then AND with payload. The length of payload is what? Now remember, we stored payload in a 16-bit variable, which means the whole length of that 16-bit is the payload. However, inside that 16-bit, we are only using 12 bits. So we are also interested in, I just enlarge this a little bit. So if we have 16 bits, these are 4. So the 12 ones, these are 12. That's the payload. We also interested in these zeros. So when we are shifting, we shift it by 16, not by 3, but we AND it with full 16 bits, not 12. Okay, we add it with 16 bits. You can, if you ask me, you can also AND it with 12 bits. There won't be a big difference, but let's just, for completeness, let's use full 16 bit any method. So 0xff, then we convert it back to, cast it back to a 16-bit integer. Okay, packet dot voltage is equal to, so I just write all of this in one step, in ht packet shift by what? This is 12, 13, 14, 15. So this is 15. Shift by 15. Then AND with 0x. Voltage is 3 bits. So 3 is what? 3 is 7. So how is that? 3 is 7. So 0x plus 7. Packet dot current is equal to uint ht packet shift by, basically you can just add this. This is 15, 18 plus 220 plus 121. Because we need the current, you add all of these bits. 15, 16. This is get current to shift this by, this is 15, 16, 17, 18, 18, not 21. 18. Then AND that with 0x So current is, what length is current? 3 bits, so 0x07 packet dot address is equal to address is unit 8, so unit 80 packet dot no, shifted by the number of bits. So address is here, so shift these number of bits, which is 12 plus 6, 18 plus 3, 21. So shifted by 21, and with the length of the bit size of address basically, which is 4 bits. So 4 bits is 0xf. So you can say, sorry, you can say this is 0xf. Okay, so we just say 0f completeness. Then packet dot parent address is equal to uint 80 packet dot no, packet shift. This is what's the length of this up to this point? So currently 15, not 21 plus 4, right? Let's see, 4, this 12 plus 3, 15 plus 6, 21 plus 4, 25. 25. And it with, that's 5 bits. So 5 bits is 1f. So 0x 1f, and packet dot read is equal to uint 8t packet dot packet shifted by the remaining number of bits, 32 minus 2, 30. But let me confirm that. So it's up to this point. So you have 25 plus 5, which is 30. Good. 30, then we AND it with, it's 2 bits, so it's 2. So decimal of that is 2. No, 3. 3, not 2. 3. So 0x3. Okay. So that's that. Let's see. T. Okay. All right. So this should be P, whatever we have here. So I'll just do that, and then the next thing we do is let's try to print whatever value that we receive here. So printf, I can say percentage hash x p. Okay, we build that dash o packet dot c packet dot c. All right, so we don't have a native support for because we didn't include std int.h. So clear this and recompile. Okay, so invalid operands, invalid operands. Okay, so what we are trying to do is whatever we receive from the user, this is p. So I'll just change this to packet value. Then this guy should be packet value here. So it should be packet value packet value. Let me change all of this to be packet value. This is the value we are getting from the user. Our packet, the packet that we want to decode. Okay. Then we take the structure and assign those member values based on what we have extracted. Okay, recompile that. Good. So unexpected before packet line 34, number 3. Yeah. Compile p and declare first, so it should be packet value. Clear that. Compile. Good. So we have 0 errors. So we try to run it. I called it packet. So packet. So 0x 1 2 3 4 A B C D. Good. So that's our value. So we want to decode this value now. It's already decoded. So what we do, we just print the decoded values. Okay. So that's easy. So print decoded values. What you do here, just say printf. Whatever you want to print is crc, for example. crc now this hash is to help you to have 0x. See that to get 0x, you put a hash in front of the hex. Okay, so crc will be percentage hash x, and then packet dot crc. Yeah, so this should be state. Copy paste here. This should be payload. This should be voltage, current, address, current address, then the read data. So this is not useful. We can just print, I don't know, something like that, then remove this. Okay, so mind you, as I said, this code is not optimized. We are wasting a lot of memory, but I'll show you how to like use that memory in a later video. So this is packet dot read, packet dot parent address, packet dot address, current, then we have voltage, we have payload, the state. Okay, so let's try rebuild it and then run. Then you say 0x 1 2 3 4 A B C D. Okay, so I forgot something very important, which is new line. I'll just add it here. New line. Okay. All right. Just make them a little bit prettier. Save, recompile. You can write a makefile for this, obviously, but for this simple example, it's not necessary. PCD. Okay. So you see, we have all this. Just clear. Compile, run 0x 1 2 3 4 A B C D. Good. So you see, we have all these uncompressed, basically decoded data types from the packet itself. Okay, I think that's it for today. So next time I'll show you how to stop wasting the 6 bits. For example, here we have at CRC. CRC, as I said, is 2 bits, but we are using an 8 bit, so 8 minus 2, 6. We are wasting 6 bits. We are wasting for the state, you are using around 7 bits. So if you have like a million of these packets in your system, you are going to waste a lot of memory, which is like one of the most expensive resources we have. Okay, so that's it. If you have a question, you can obviously ask, and see you next time.